Click the bell icon to get latest videos from Ekeeda.
Hello friends, I welcome you all to this video. We are with 10th chapter of microwave engineering, and with this topic we are basically going to conclude this chapter. So far in this chapter we have gone through the understanding of what exactly the basic types of transmission lines called as strip lines and its modified form after removal of a ground plane, that it is microstrips. So after introduction and the comparison of the two, we have solved selected problems onto the strip lines, microstrip lines. We have derived the characteristic impedance and some related parameters to the performance of this transmission also. The various forms of strip lines we are dealing with as like the parallel strip line and the previous topic that it was coplanar strip line. So we have solved one problem onto them also. So let us have addressing to the shielded type of the strip line, and after one problem we shall be finished with this chapter. So let us see the details. So here we start with our topic titled shielded strip line. So as we come to see the term shielded strip line, the strip lines are the basic transmission line that we have been dealing throughout this chapter. Now what is the new thing with the name given to it as shielded? So a shield means a kind of protection, a kind of envelope that will protect the inside structure from the damage in general, I can say here. So for the shielded strip lines here either we can have a complete or a partial type of the shielding here. So how the shielding can be made to the structure of strip line that has a strip conductor at a positive potential and a ground plane with the help of separation by a dielectric substrate. So let us see with the help of schematic diagram. So in this diagram we see a cross-sectional view. So into the two dimensions we have this view. This is the central strip conductor. So as usual we have been denoting the dimension along the horizontal line, that is at broader value represented by capital W, and it is carrying the higher positive potential here. So the most of the information is associated with the flow with this central conductor, strip conductor we can name it, and it has the thickness denoted by small t. Whereas this strip conductor is surrounded here by the dielectric material represented by the relative dielectric constant epsilon suffix r. In another words also we can say, if the dielectric material is on all the sides of the strip conductor, the strip conductor is basically embedded inside the dielectric material which has the ground planes on both the sides. So basically we say ground planes because they are at zero potential, but most of the time when we have a partial type of the shielding, these conductive materials will be working to have protection type also. So when these planes are not having any kind of connection, electrical connection made to it, and only the information supply is given to the central conductor along with the help of dielectric, the microwave transmission over this type of the transmission line can be further. So this is the shielded transmission line here. One more dimension is to add here in between the two shields, I can say, as they don't have been provided either a grounding or electrical supply. So this is simply small d here. So this is partially shielded strip line. We call this shielding to be partial because we have given shielding onto the top and the bottom wall only, whereas the two lateral sides are open, but the central conductor is somewhat protected because of the presence of the dielectric substrate there. Now the very important thing with any of the transmission line is value of its characteristic impedance. So the characteristic impedance as usual we shall denote by the representation Z suffix 0 measured in terms of ohms, and to see the various dimensions corresponding to the last schematic here, the characteristic impedance is given in the form of equation. The RHS it is having the 94.15 divided by square root of epsilon r in multiplication to a bracket that has been inverse there. So it has the power -1. It includes the two terms. First term is the ratio of W by D. W is the width of the strip conductor, whereas a D is the height that separates the two shielded forms of the planes that protect the strip conductor there. Now this is in multiplication to capital K, and further it is added to C suffix F divided by 8.854 times epsilon R here. So let us say this is equation number 1 for the corresponding characteristic impedance here. So in this equation I can write where we have capital K is equal to 1 upon 1 minus T divided by D here. This is the ratio T by D, where the T as usual it is the thickness of the strip here, and D is the distance for the separation of the shields or the ground planes in general. I can say distance between ground planes. So next to these, on to the right hand side at the second term inside a bracket that has been inverse power, we have C suffix F. So C suffix F is nothing but the fringe capacitance calculated as 8.854 into epsilon R, the relative dielectric constant, which is divided by the constant pi here in multiplication to the square bracket. The square bracket involves twice into capital K. Just now we have represented its corresponding formulation. In multiplication to the natural logarithm taken over the bracket capital K plus 1 minus, here we have capital K minus 1, ln of the operative bracket for the natural logarithm is K square minus 1 applicable to this one. So this completes the square bracket, and this is called as just now we have said, this is the fringe capacitance. This fringe capacitance is measured in terms of picofarad per unit length in terms of meters here. So these are the two formulae corresponding to the characteristic impedance which require the value of fringe capacitance along with the dimensions. So both of these formulas we shall be using in the next lecture to have computation of characteristic impedance corresponding to the shielded strip line. So here we shall be concluding this chapter, transmission, with the help of strip lines to be the transmission line there, and by the next lecture we shall see the various resonance condition possible for microwave signals, either with the cavity resonators or with the help of lumped elements. So I hope you enjoy learning the subject microwave engineering. For more such information and gaining the knowledge, you can subscribe to Ekeeda channel. Thank you.